Okay, now we're going to look at reduction formulas. And reduction formulas are used to reduce the powers of trig expressions that involve even powers of sine and even powers of cosine. These are mostly used when you're in calculus, when you're integrating. It's hard to integrate every single function, so there's a lot of rewriting that goes on, and these formulas are particularly helpful. My worksheet looks a little bit funny. Yours is going to look better because I've made the correction. I had to handwrite the angle in there because it didn't show up. So yours should look better. But these are the reduction formulas. Sine squared of theta is equal to 1 minus the cosine of 2 theta over 2. Cosine squared of theta is equal to 1 plus the cosine of 2 theta over 2. Tangent squared of theta is equal to 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. Now, we can derive these fairly easily using the double angle formula. So if you recall the double angle formula for the cosine of 2 theta, which you've been working with or been introduced to, there's three different options here. One is that it's equal to 2 cosine squared of theta minus 1. Another is that it's 1 minus 2 sine squared of theta. And then the other one is cosine squared of theta minus the sine squared of theta. So if you are trying to verify an identity, you might choose a specific one depending on where you're headed, what you're trying to accomplish. I want to come up with one of these. So what I'm going to do is start with this. 2 cosine squared of theta minus 1 is equal to the cosine of 2 theta. All right. I'm just going to simply solve for the cosine squared of theta. So the cosine squared of theta, 2 cosine squared of theta is equal to the cosine of 2 theta plus 1. And then if I divide both sides by 2, I get 1/2 times the cosine of 2 theta plus 1, which is the same thing as this right here. I can rewrite this as 1 plus the cosine of 2 theta. That's the reflexive property. And I could write this as over 2 or multiply 1/2. It's the same thing. You can do exactly the same thing for sine squared. Pick this middle identity. 1 minus 2 sine squared of theta is equal to the cosine of 2 theta. And just simply solve for the sine squared of theta. Negative 2 sine squared of theta is the cosine of 2 theta minus 1. I'm going to divide both sides first by negative 1. So if I divide this side by negative 1 and this side by negative 1, I get 2, positive 2 sine squared of theta. If I divide this by negative 1, this term becomes negative, this term becomes positive. So this can be written as 1 minus the cosine of 2 theta. And then divide by 2 finally. 1/2 times 1 minus the cosine of 2 theta. This last one can really easily be solved by, we know that tangent is equal to sine squared of theta over the cosine squared of theta. So the sine squared of theta is this. The cosine squared of theta is this. If I take this divided by this, the 1/2 will cancel and I'll have exactly that. Okay, so now let's see, how would we rewrite these? So our instructions for all three of these are examples are to rewrite the expression with a power no greater than 1. So what that means is currently the power is 2 sine squared. I need that to be the highest power of 1. This is a 2. I need to rewrite that as something to the first power. This third one is something to the fourth power. I need to rewrite that as to something to the first power. So this is all we do. We say, okay, I have this newly established or newly introduced formula, reduction formula right here. And that sine squared of theta is equal to this. Or if I want to look at this, it's the same version. So sine squared of 2x is equal to 1/2, I'm going to use this, times 1 minus the cosine of 2 times theta, but theta in this case is 2x. So I get 1/2 times 1 minus the cosine of 4x is what that's going to look like. You could distribute the 1/2 if you wanted to. You could write it as a single fraction with a denominator of 2, but that's the answer to that. Okay, very simply, the next one, cosine squared of 6x is equal to, okay, well, the cosine squared of an angle theta is equal to this right here. So cosine squared of 6x is going to be 1/2 times the cosine of 2 times theta. But theta in this case is 6x, so 2 times 6x plus 1. So this becomes 1/2 the cosine of 12x plus 1. Again, you could distribute the 1/2 if you wanted to. All right, now what do we do when it's not just sine squared or cosine squared? There's something bigger, like to the 4th or 6th or 8th power, something like that. It has to be an even power, by the way, if you're just trying to reduce it to ones. So let's see, what we do to the 4th power? Well, you can say this is the sine squared of 8x squared. That's what that is. And so then you can say, well, what is the sine squared of 8x? Well, we can use this reduction formula to rewrite sine squared of theta into something else. So sine squared of 8x would be 1/2 times 1 minus the cosine of 2 theta. But my theta is 8x, so 2 times 8x would be 16x. And now this is being squared. All right. Well, let's see. What I'm going to do this time is distribute this 1/2. So this is going to be 1/2 times 1 is 1/2 minus 1/2 times the cosine of 16x. And this whole thing is being squared. But this is a binomial. This is a minus b squared. And this is equal to a squared minus 2ab plus b squared. So this will be 1/2 squared, which is 1/2 times 1/2, which is 1/4, minus 2 times a times b plus b squared. So this is b. 1/2 squared is 1/4, and this is the cosine squared of 16x. So it's looking better. This is 1/4. Oops, that's going to be minus 2 times 1/2 is 1. But so I still have this 1/2 cosine of 16x plus 1/4 cosine squared of 16x. And so the instruction said, write everything so the highest power is 1. And I still have a power of 2. I'm going to have to do another rewriting. And so it's not going to be hard, though, because I'm going to use this guy right here. So this is equal to cosine squared of 16x is equal to 1/2 times the cosine of 2 times theta, but this time theta is 16x. So 2 times 16x is 32x plus 1. We could just use that formula again. And I think you can see that. You can keep doing this. What if you had something to the 30th power and you had to rewrite it? You could keep breaking it down and breaking it down. All right, so let's see here. This will be 1/4 minus 1/2 the cosine of 16x. 1/4 times 1/2 is 1/8 the cosine of 32x. And 1/4 times 1/2 times 1 is 1/8. So what I can do here is I can combine these are like terms. 1/4 plus 1/8 If I get a common denominator of 8, I said 4 times 2 is 8. 1 times 2 is 2. Now I can add those guys. So this is 3/8 minus 1/2 the cosine of 16x plus 1/8 the cosine 32x. And that is the equivalent to sine to the 4th of 8x. All right, that's this one.